Good morning, good afternoon or good evening whenever you watch this video. Today we're going to make a drawing of the cross-section of the fuselage. We have a 9 step procedure to follow. This is, can be found in the slides, and this is the procedure we're going to follow. We have a setup here where we have all the necessary slides made available. We have the data sheet, the aircraft design data sheet, and we have some data given and some data we need to calculate based on the work we're going to do. Here we have the first sheet of graph paper, A4 graph paper, and here's where we're going to draw the cross-section of the fuselage. The example I will be using today is from the exam of April 2019. So you can look it back, April 2019. This is the data we have been given. It's an aircraft for 105 passengers. We have some cabin data given, so you don't need to calculate that in this case. But we have been that given as a starting point, and we need to make a start and then basically try to follow this procedure. Step 1 says compute the dimensions of the passenger cabin. Well, for the dimension of the passenger cabin, we look at this slide, and here we see all the elements we need to put in there. We start by drawing a floor, and then we place the seats, we place the aisles, we place the headroom, place the clearances. And with that, we can just find the dimensions. After that, we're going to find the corner points and then try to draw the smallest circle around it. So that's the plan. I have some drawing equipment available here. You can maybe recognize an old-fashioned drawing machine for this. We'll not use that. We'll use standard equipment. We'll use a ruler. We need a calculator to calculate a couple of things. We have this little device, which is called a protractor, or in Dutch geodriehoek. Cost about 50 cents and it's a very handy tool. You definitely must buy one. Then we have a refillable pencil. This is a one which has a diameter of 0.5 millimeters. You have to be careful with that. If you're a bit more sturdy in using your pencils, you can go to a bit thicker one. This is a 0.7 millimeter pencil, but then the lines become thicker and the drawing becomes less accurate. And of course, we need a compass. This is not a naval compass, but this is one just to draw circles. And of course, it's possible that you make mistakes, so also an eraser is very handy. So that's the tools we're going to use today. So let's make a start. The first step, compute the dimensions. Well, what we have already been given is the aisle width here. So we can put that into the formula. We have 0.6 meters for the aisle width. We have the width of the seat, and then of course you can say, okay, this one individual seat that we have here has a width of 0.44 millimeters, 44 centimeters. But we need to know how many seats we have. So to determine how many seats we have, we first need to calculate the amount of seats abreast. So that's where we're going to do a first calculation. What we need to do is take a look at the number of passengers, plug that number into the formula. There's this formula with the square root, and then you'll figure out that the seats abreast is a little over 4.5. Well, we don't put half passengers in the seat, so we round that up to 5 seats abreast. So in total we will have 5 seats abreast. This is an aircraft which has less than 6 seats abreast. That means we have one aisle only, so we have one aisle, only one aisle. That we'll take into account, but we have 5 seats. So we have 5 seats, number 5 seats abreast, times the width of the seat, 0.44 millimeters. Then we have, of course, to take into account the room for the armrest. We will have the number of seats plus the number of aisles plus 1 armrest. So we have 5 plus 1 is 6 plus 1 is 7. 7 multiplied by the armrest, and the data for the armrest has been given as 0.05 meters, so 5 centimeters, so multiplied by 0.05. We have one aisle, that's what we already calculated, multiplied by the aisle width of 60 centimeters, and then we need 2 times the clearance, and the clearance has already been given as 2 centimeters. So plus 2 times 0.07 2 meters. And then we have all the elements for the width of the cabin, and then we can start our drawing. So let's see what we have. 5 times 0.44 meters, plus 7 times 0.05 meters, plus 1 time the aisle, 0.6 meters, plus 2 times 0.02 meters, is 3.19 meter. So this one is 3.19 meter. Then we need to find the headroom. The headroom is this width here, the width at the headroom. So we will have a fuselage which will be looking like this, and of course the space available will become less if we start from the widest point, and we need to find out how much space we really need here, because this will be one of the corner points in the design. So let's do that. Headroom is given as the width of the cabin. We just calculate that as 1.39 meters minus 2 times the width of the armrest. The armrest we get from the graph again, for the table again, 5 centimeters, plus 1 time the clearance was 2 centimeters, 0.02, close bracket, minus the width of the seat, and the width of the seat we already used before, 44 centimeters, 0.44 meters. Make the calculation again. So what we will see is that we have 3.19 minus 2 times open bracket 0.05 plus 0.02 close bracket minus 0.44. That's 2.61 meters. So we have some principal dimensions. Okay, that means that we can now start our drawing. And since we don't know where the center line is going to be, because we have an odd number of seats, we cannot split them 2 on the left hand side, 2 on the right hand side. That's 4 abreast, or 3, 3. We have 5 seats abreast, so it's going to be a 3 plus 2 split. So the aisle will not be in the center line. So that means we will not be able to draw the vertical center line of the fuselage yet. We will do that later on. So what we'll do in this case, we'll start by giving the floor, so we'll draw the floor. I can do that with this machine, of course, that's an easy one, but I'll do it like you will be doing, just with my ruler. And I'll just set the floor somewhere on my drawing. Make a nice straight line. Do it a bit below the middle of your picture. A nice straight line. So that's going to be my floor. I'll just write it here, so we know what we're talking about. And now what we're going to do, we're going to define all these blocks, all these rectangles, on the basis of the data we have so far. So the first one is that we will have a shoulder height, because that will be the height of this block. So I'll like to draw this line here. And the shoulder height has been given as 95 centimeters. Now, 95 centimeters has to be converted into the scale of this drawing. And the assignment of this exam said a scale 1 to 25 scaling. So I have 95 centimeters and divide that by 25. That means 3.8 centimeters or 38 millimeters. So that line, this line that I'm going to draw here, is going to be 38 millimeters above the floor line. The nice part of this graph paper is that this is indicated in millimeters. So 3.8 centimeters is a little bit less than 4 centimeters. And these blocks are 1 centimeter large, 10 millimeters by 10 millimeters. So I can use this one. Again, I'm just going to draw a parallel line for the shoulder height. So this is the line for the shoulder height. Let's call it H sub SH. Okay, now we have done this line. Then we need the width here, and there we need the 3.19 meters. So what I'm now going to do is make a block, a rectangle, on the floor, which is 3.19 meters wide. Again, using the scale of 1 to 25. So 319 centimeters divided by 25 is 12.76 centimeters. So I need a space of roughly 12.8 centimeters. To make the drawing a bit more symmetric, you can make use of this device now, because this has an even distribution from the middle. So what I need to do, I need to divide this by 2. So 6.38 centimeters, so 64 millimeters. And I'm going to make this more or less in the middle of the picture. It doesn't really matter when it's really aligned or not, but more or less in the middle of the picture. And then I'm going to draw the line. So let's say I'm going to use this point as my center line, and then we're going to be 6.4 centimeters to this side and 6.4 centimeters to this side. And the nice part of this thing is that you can make perpendicular lines, because now we need to draw a perpendicular line over here from the floor to the shoulder height, and we'll do the same over here. You can nicely line this up. And then we have the block for the shoulder height. Now we have just drawn this block, width of the cabin, shoulder height, all inclusive. Now we need to take the headroom, and the width of the headroom is centered around the seats. One edge lines up with the middle of the most left-hand seat, and the other one lines up with the center of the most right-hand seat. So what we need to do, from the edge of this block, we need to go inward on both sides. How do we do that? Well, it's the middle of the seat. The seat was 44 centimeters wide, so that's the half of the seat is 22 centimeters. But we must also take into account the fact that there is a clearance and there is one armrest to be taken into account. The clearance from the table was 2 centimeters, the armrest 5 centimeters. So we go in 7 centimeters plus 22 centimeters from the edge. So we have 7 plus 22 centimeters is 29 centimeters, divided by the scale, 1 to 25 again. So it's roughly 1.2 centimeters, 12 millimeters. So we go in 12 millimeters from this side. This is from this side. Of course, we'll do the same from the other side, 12 millimeters from this side. And then we need to make this such that we also draw in the headroom height. So this height we have over here, that has been given as 1.5 meters. 1.5 meters, 150 centimeters divided by the 25 gives me 6 centimeters, 60 millimeters. So we need to go up from the floor at this point to a height of 6 centimeters. We'll do the same at the other side. From the floor, nicely perpendicular, we go up to 6 centimeters. And then we draw a horizontal line again. And you can do that with the ruler or with this protector. And then we have the headroom height. So let's make it here. Here we have the shoulder height. And here we have the headroom height. If you like, you can draw in all the seats, but that's not required for finding the dimensions of the fuselage. But if you have some time left, you can nicely draw the seats and the armrest and all these kind of things. But that's not really required. The next thing we need to do is to figure out where the aisle is. And the aisle is not in the center of the fuselage. We can draw the center line of the fuselage in the meanwhile, because we have chosen a center line point, because we chose this point. So in principle, we can already now draw the center line of the fuselage, at least the vertical center line. So that we'll do. We have a dashed dot line, which is the center line of the fuselage. So here we have the center line of the fuselage. Now we need to figure out where the aisle is. And that requires some calculation again. Let's do it from the right-hand side counting. We'll start here at the far edge. We have a clearance. We have 2 centimeter clearance. We have, in this case, one armrest for this seat. So that's 5 centimeters. We have one seat, 44 centimeters, plus another armrest, 0.05, plus another seat, plus another armrest. And then I have the edge of the aisle here, assuming that I have 2 seats on the right hand side and then the remaining 3 on the other side. So let's add that up. We have 0.02 plus 0.05 plus 0.44 plus another armrest plus another seat plus another armrest. That is 1.05 meters. 0.05 meters. 105 centimeters divided by 25 again, that's 4.2 centimeters, 42 millimeters. So my aisle is going to start 42 millimeters from this edge. I'm going to be over here. I can draw a vertical line over here. And now you probably see that you run into the limitations of this device, so you need to move it up if you want to go further. But we'll talk about that in a second. We need to take into account the width of the aisle. The width of the aisle has been given as 60 centimeters. So 60 centimeters divided by 25 is 2.4 centimeters, 24 millimeters. So from this point on, let's start here at the bottom. 24 millimeters over here. Make a perpendicular line. And now we need to figure out what is the height of the aisle. That has been given as 2.16 meters. Let's do the calculation again. 216 centimeters divided by 25, 8.64. 8.64. Okay, we need 8.64. You will see that this device only runs to 7 centimeters and not to 8. So you need to move it up. Let's move it up to starting at 2. And then we have 8.64 is roughly here. So this is going to be the height of my aisle. Make use of the nice perpendicular lines on the graph paper to make nice perpendicular lines in your drawing. So here we're going to have the top of the aisle. We can now extend the sides of the aisle. And then we can nicely complete the aisle. Use the eraser again to get rid of the lines which are not necessary anymore. And here we have the aisle height. And also the width, of course. So now we have all the elements in this diagram. And that means now we can try to figure out what is the smallest diameter we can draw around that. In this case, there is no cargo in the assignment. If there would have been a cargo requirement, we would need to take into account the space here. And if you want to do that, you first need to draw in the structural thickness of the floor. Well, has there been something given about the structural thickness? Yes, the floor height has been given as 20 centimeters, 0.2 meters. So 20 centimeters divided by 25 would have been 0.8 centimeters or 8 millimeters. So you would need to draw the floor height in there. This is the structural thickness we need for the floor. And then you would need to draw a cargo container here or suitcases or whatever. In this case that was not required, but you would need to do that if that would be required. So here we have the floor thickness. Let's write it here, floor. The floor thickness, but we don't need that, so now we can move on without any problem. The next step, because now we're more or less already quite a bit on our way in our plan, we have the dimensions, we have the upper deck space allocation, we have the floor structural depth, we have, well, in this case no cargo, and that means we're now at step 5. We need to identify the corner points. We have corner points We have a corner point over here. We have a corner point over here. We have a corner point over here, over here, over here, over here, over here, and over here. And if there was cargo, there would be a couple of corner points down below. And now we need to find the smallest circle that you can draw around this point. You can do that with a lot of trial and error. Use this the compass, the geometric compass, and try to figure it out. How do you do that? Well, in principle, you put the sharp point somewhere on the center line. That's why we need the center line in the drawing, and try to find something which goes around it. But there's a smarter way to do that. And the smarter way works as follows. The first thing you need to do is to make an estimate of the corner points you think will be limiting. It's not a problem if your first choice is incorrect. You can always correct it. That's why I use light pencil strokes. But let's suppose we assume that this point and this point is going to be limiting. That the circle has to touch these points, and that's going to be limiting. How would you then find the nearest circle? Well, effectively what you need to do, you need to find a circle which has this point and this point. But that again requires some trial and error. But the fastest solution is as follows. You draw a straight line between these 2 points. Straight line between these 2 points. Then you reverse this triangle, and then you're going to find the middle of that line. And then the nice part of this protector is that it is equally divided. 7 centimeters on this side, 7 centimeters on this side. So it's easy to find the center. And that's going to be roughly here. I'm going to indicate the center of that line. And from that point, I'm going to draw a perpendicular line, again with the help of this device, until I touch the center line of the fuselage. And then I find this point over here. And that will be the center of the circle that will touch both points. So I'll put the sharp point over here. I'll measure it such that I have 1 point, and I will see that automatically I have this point as well. And then I draw my circle. At least the first estimate of my circle. And what you see now, that this is not the correct circle. Because we will see that this point is okay, this point is okay, but this point is not okay, that falls within the circle. This point is also not okay, does not fall within the circle. This one is okay, this one is almost okay, and this one and these ones are okay. So this is not the correct circle. So we need to do another attempt. So my next attempt is going to be to look at these 2 points. So that might be the critical point. So here you see the benefit again of using light pencil strokes, because now you can remove the incorrect circle. You can also remove the additional line. Let's do it like this. And again, use the same trick. My guess is that this one and this one might be limiting. Again, draw a straight line. And then again, you see you have immediately a problem. What's wrong here? Well, what's wrong here is that you now aim at this highest point, but is the width of this whole row of seats that is probably more limiting. So you need to probably aim for this point and this point, or this point and this point. So let's do so. Again, remove the line here. You can also remove the auxiliary line. And let's apply the trick again. Let's say, okay, now expect that these 2 points will be limiting. Again, you see that this is not a solution. You will be out of the corner points here. But all the other ones, they are okay. So we slowly but steadily are getting there. And again, this is requiring some trial and error to find the nicest solution. So we have to take into account that This point might be limiting. This point will probably not be that limiting, but maybe this one will be limiting. So let's see if we find a combination between these two. In this case, you see that I'm skipping that point, and you can do that because you will have a circle, and that circle will be going around this point. So we can skip that point and we can make the line between these 2 points, hoping that this will be enough. And then find these points. You see it nicely goes around there. And there we have a new surprise. Now it looks like everything is okay, but we'll see that we are in trouble in this point. So it's even going to be more complicated. And this is a whole iterative process you just have to go through to see what is the problem. So you need to take into account this point as well. Now, and you have to find the most critical combination. So it probably makes sense to start looking a little bit in what might be critical combinations. It might be that is these 2 points. It might be that is these 2 points. Then hoping that by the circle this point will be within the circle, or it may be these 2 points. Now you see, if I take these 2 points, these points are pretty far outside of the intended circle. So that's probably not the right combination. And it's doubtful whether, if you take these 2 points, this one will be within the circle. So my guess is that we have to take into account these 2 points and then make the circle around that. So let's try that. In this case, it is already indicated by a line, so we just have to find the middle of that line. This one is exactly in, and then you see this one is not going to be in. So again, this combination is not correct. So we have to find another solution for that. The tricky thing here is that you have an asymmetric fuselage cross-section, so that the fact that this is not symmetric makes life a bit harder for us. But let's just try to solve the problem. Okay, let's try to get an indication first on how critical things are going to be. Suppose we take this point, then we see that's not enough. Then we have a problem, because then we saw that this point is going to be tricky. So maybe we need to take into account this point and this point. Then you see probably the other parts will be in. And if you go around, you see that probably the other side is going to be okay as well. So let's again take this point, and let's take this point and see where that's enough. And now we'll see that everything will work out. I have to nicely align this. Going around, touching that point, free from the other point. And here we have our circle at last. So this can be a rather tricky process. This will take some time normally, but now we're there. So what we've done, we have computed the dimensions, we have the upper deck, the floor structure. In this case it was not relevant, we had no cargo, or some lower deck situation. We had a corner points, we have now drawn the smallest circle around it, and then the next step is measure the inner diameter of the fuselage. In this case, we have an asymmetric division of the seats here. So it's a bit tricky to figure out where exactly is the other center line. But the best way to do this, make use of the center line that has already been given here. So make use of the vertical center line to measure that. I'm going to use my protractor again. I'm going to add this to the top point. That is going to be like this. And then my bottom point is here. That means I have 7 centimeters plus 6.6. So we have 13.6 centimeters. and we need to multiply this by 25 because we have the scale of 1 to 25. We have 13.6 times 25. That gives me 3.4 meter. 3.4 meter is going to be my inner fuselage diameter. And I can draw that in the diagram. So the primary dimension is going to be 3.4 meters. Okay, step 6 done. Now, step 7 says compute the outer diameter and draw the outer wall. How do we need to do that? Well, we need to go to this slide, the structural dimensions. We do have the structural dimension of the floor because that has been given, but for the structural dimension of the wall, we use the formula for large transport aircraft, because this is not a fighter or a trainer, and this is not a small commercial aircraft with 20 passengers. So we'll make use of this formula here, which says it's 1.045 times the dimension, and we use meters here, so 3.4 meters times 3.4 meters, and we have to add 8.5 centimeters, 0.084. So my outer diameter is going to be 3.59 meters. I have to again divide that by 25 to bring it back to the 359 divided by 25 to bring it back to the scale. So that leads me to 14.36 centimeter on the drawing. So that's what I'm going to do. I'm going to take half of it because I'm going to set the diameter using the compass again. I'm going to figure out how this dimension is there. So what I'm going to do, this was the center point, and I'm going to make use of 7.2 millimeters. This is 7, and then I have to add 2 millimeters over here. This is going to be my point over here. I have my center line, my center point over here. Size this. So here I have my outer diameter, and the best way is to also indicate that dimension. So let's do that here. So I have computed that. I've drawn the outer wall, and then step 8 is the cargo floor. In this case there's nothing been given, but you could draw a cargo floor. That could, for instance, be here. Because the cargo will not be resting on the bottom of the structure. You'll probably want to feed some cabling through there, or some ducting. So we can have a cargo floor here. Nothing has been given, so this is okay. And we can add overhead bin space. In this case, let's make these lines a bit more clear in this drawing, so we know that this is the headroom space. So above that there will be the luggage bins. So in this case that's just going to be an artist impression. That could be something like this on both sides of the aisle. And of course, with modern aircraft you would like to have the cargo bins as large as possible. So in a real aircraft you would have some dimension of suitcases you want to bring along, but that is going too far for this lecture. Okay, the last thing we need to do is to, of course, add the center line, the other center line, the horizontal center line, with the ruler nicely aligned with the graph paper. Make it a nice dash dot line again. So this is how you make the cross section of the fuselage, and now we have the dimensions, and that we can put on the large drawing where we'll be having a top view, a side view and a front view of the aircraft. but that's for the next lecture.